Hello everyone. In the previous topic, we talked about limits. We explained what are limits, the concept of limits, and then we talked about why do we need limits and why are they important. And I told you that I will be also doing different limits for different types of functions on how do we actually find limits. But we ran out of time in the previous topic, so this is what we're going to be doing today. But first, Assalamu alaikum. Welcome to my channel, FM Math, providing physics and mathematics tutorials for secondary level and beyond. Make sure that you subscribe so you can easily find all lessons and write down any requests you have in the comment section so they may be added in future videos. Now, going back to the topic at hand, how do we find limits? Well, the basic concept of finding any limit is substitution. Just as we find the function at any value by substituting that value, we find the limit of any function when x approaches a value by also substituting that value. And so if I have a function like this, simple function, polynomial one, 3x plus 1, with x approaching 5, all I have to do is just substitute x as 5. So I'm going to have 3 multiplied by 5 plus 1, which is going to equal 16. Simple and easy. Why simple and easy? Because this function here has a domain of all real numbers. If a function's domain is all real numbers, then simply by substituting, you're going to find your limit directly without any hassle. And not just that, the limit is going to be equaling to the function itself. The function of 5 equals 3 multiplied by 5 plus 1, which is also 16. And in this case, you say that the limit of f of x when x approaches 5 equals f of 5. Again, why is this? Simply because the domain for this function is all real numbers. And for polynomial numbers, polynomial functions, that's it. You just substitute and you find it, and it's equaling to the function itself. Not just that. Let us say that we have two functions. Here I have f of x as x squared and u of x as x plus 1. What is the limit for f of x multiplied by u of x? Here I'm looking for the limit of the product of the two functions. So the limit when x approaches 2 of x squared multiplied by x to the plus 1, which equals the limit when x approaches 2 of x cubed plus x squared. Now, before I go, a lot of people make the mistake of here we just rearranged the function of we just wrote a different format for the same function. So a lot of people make the mistake of when they're doing adjustment on their functions, they just do like this. They say the limit blah 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 equals x cubed plus x squared, and that is wrong. Well, because here this is not the limit, this is just a rearranged formula. So this is not the limit, and I'm sure that the limit of x cubed multiplied by x squared multiplied by x plus 1, it does not equal x cubed plus x squared. This is not the limit. So you have to make sure that whenever you write the equal sign, whatever on the right hand side of that sign equals whatever on the left hand side of that sign. The both ends of this sign must equal. You have to make sure that of that before you write the equal sign. So this equals again the limit of x cubed plus x squared when x approaches 2, and that equals 2 to the power of 3, which is 8, plus 2 to the power of 2, which is 4, which equals 12. What if I find the limit for both functions and then I multiply those limits? Okay, the limit of f of x when x approaches 2 equals, remember that f of x is x squared, so it equals 2 squared, which is 4. And the limit of u of x when x approaches 2, remember that u of x equals x plus 1, so it equals 2 plus 1, which equals 3. Now the product of those limits equals 4 multiplied by 3, which equals 12. And this is the same here. So when you're dealing with polynomial functions, also the limit of the product of 2 functions or 3 functions or 4 functions or 5 functions is the same as finding the limit for all of those functions and then multiplying them by each other, provided that x approaches the same value in all of them. Now let us talk about rational functions. Now in rational functions, we're going to be talking about 2 cases. When x approaches infinity and when x approaches a value that will make the denominator equals 0. Starting with x approaching infinity. Now when x approaches infinity, I'm faced with the problem of infinity itself. Now infinity itself is not an easy number to deal with because I'm probably going to end up with just infinity over infinity or something like this, which is not a real value that I can actually deal with. Because probably when I add, subtract, or multiply infinity, I'm just going to end up with infinity itself. But I can actually divide by infinity. Let me show you how. If I have 10 divided by 1, that equals 10. 10 divided by 2, that equals 5. 10 divided by 5 itself equals 2. 10 divided by 1 equals 10 divided by 10 equals 1. Notice that the higher the number I divide with, the smaller the value I get. So what if I divide 10 with a number that is so large? Let's say infinity. Well, that means I'm just going to end up with a value that is so small, and this value is approximated as 0. So when I divide anything by infinity, I'm just going to end up with 0. So I need to divide by infinity. How am I going to do so? Okay, we're going to divide all terms of the function by the highest power of x, by x to the highest power. What is that highest power? Well, that highest power in this function here is 4. The highest power here is x to the power of 4. So all the function is going to be divided by x to the power of 4. Okay? So it's going to be the limit when x approaches infinity of x to the power of 4 by x to the power of 4 plus 5x by x to the power of 4 minus 1 by x to the power of 4 divided by 2x to the power of 4 by x to the power of 4 plus 3 by x to the power of 4. And this equals the limit when x approaches infinity of this equals 1 plus 5 over x to the power of 3 minus 1 divided by x to the power of 4. All of this is divided by 2x to the power of 4 by x to the power of 4. This equals 2 plus 3 by x to the power of 4. And now I can substitute all of the x's by infinity. So it equals 1 plus 5 over infinity plus 1 over infinity divided by 2 plus 3 over infinity. Now this is 0, 0, 0. So what I'm left with is 1 over 2, and that's the limit of the function. So the limit of this function when x approaches infinity is just 1 over 2. So whenever I'm faced with the rational function or a function that approaches infinity, by dividing the function, even if it was polynomial, by dividing this function with x to the highest power in the function itself, I'm going to find the limit of that function. The second case here, I have the limit of this function when x approaches 4, and we can say that the domain of this function, just as a function, the domain of this function is all real numbers except for one number, that is 4 itself. So when I'm substituting in this function, I'm going to get 0 in the denominator. So what am I going to do? Well, first of all, we need to substitute as usual. So it's going to equal 4 squared minus 2 multiplied by 4 minus 8 divided by 4 minus 4. This equals 16 minus 8 minus 8 divided by 4 minus 4, and this equals 0 by 0. So okay, what am I supposed to do here? Well then, you're going to be doing 3 steps. The first step is factorize. Look for the factorizable expression in the function, and the factorizable expression in this function here is the numerator. So it's going to be the limit when x approaches 4 of the factorized form of this expression here is x minus 4 and x plus 3. The 4 multiplied by 3, sorry, 2. Negative 4 multiplied by 2 equals negative 8, and negative 4 plus 2 equals negative 2. This divided by x minus 4. Now I have factorized. Then I go to the second step, cancel out. Well, x minus 4 here can be cancelled by x minus 4. So I'm ending up with the limit of x when x approaches 4 of just x plus 2. X minus 4 now is cancelled with the other x minus 4. The third step, which is the final, substitute. Now I can easily substitute this function by 4. So it becomes 4 plus 2, which equals 6, and so I have found the limit for this function. Now bear in mind that f of 4 cannot be found for this function, but the limit is found, which is 6. And this is part of why do we need limits, to find what does the function approach when x approaches a value, that is out of the domain of the function. I am sorry for that sound. I'm not very good with editing, so I cannot actually take it out of the video, so I'm just sorry for it. Let's take another example. Let's find the limit of x to the power of 4 minus 625 divided by x minus 5 with x approaching 5. If I adjust this expression a bit, I will find that it equals the limit of x to the power of 4 minus 5 to the power of 4 divided by x minus 5 when x approaches 5. So why did I do so? Well, because there is a rule that says the limit of x minus a, x to the power of n minus a to the power of n divided by x minus a when x approaches a equals n multiplied by a to the power of n minus 1. So I have the limit of x minus a raised to the same power divided by x minus a, and x approaches the same value of a. So it is the same as this here. That's why I edited this a bit. I have x minus 5, both are raised to the same power, which is 4, divided by x minus 5, and x approaches 5. And so by applying this rule, I will find out that this will equals n is 4 multiplied by a, which is 5, to the power of n minus 1, which is 4 minus 1. So it equals 4 multiplied by 5 to the power of 3. And this equals 4 multiplied by 125, which equals 500. So if you find a limit that looks like this, you can simply just use this rule, and if it doesn't look like it right away, you can try to make it look like it, and then use the same rule. There is another rule that says the limit of x to the power of n minus a to the power of n again divided by x to the power of, let's say, m minus a again raised to the power of m. It's the same as this, but here the denominator is raised to another power when x approaches a. Now in this case here, the limit is going to equal n over m multiplied again by a to the power of n minus m. An example, let's find the limit of x to the power of 5 minus 243 divided by x to the power of 4 minus 81. It doesn't look when x approaches 3. Now from the first look, it doesn't look like this, but those two numbers might be modified so it looks like this. So you can say that it equals the limit of, when x approaches 3, of x to the power of 5. Now I know the base is 3, and I know the power is 5. So it's just going to be 3 to the power of 5. All I have to do is just make sure that 3 to the power of 5 equals this, divided by x to the power of 4 And again, I know the base is 3 and I know the power is 4, so it's going to be 3 to the power of 4. You only have to do is make sure that 3 to the power of 4 equals 81. And so this is going to equal n over m. N is 5 and 4 is m. So n is 5 and m is 4 and a is 3. So 5 over 4 multiplied by 3 to the power of 5 minus 4, which equals 15 over 4. And that's it for rational functions. Like, what about trigonometric functions? For trigonometric functions, we have basic rules. The first of them is the limit of sine x when x approaches 0 equals 0. And the limit of cosine x when x approaches 0 equals 1. And the limit of sine x over x when x approaches 0 equals 1. Now, if you want me to prove those three rules, I can do so in a separate video, so you can write that in the comment section. But in order to save time, I'm not going to do the proofs here. We're just going to be doing examples. So an example, let's prove that the limit of tan x divided by x equals 1 when x approaches 0. Of course, when x approaches any other number than 0, we can we can substitute, but when x approaches 0, this is the case here we're dealing with. So, well, tan x over x equals sine x divided by cosine x, and this is divided by x, or multiplied by 1 over x. So it equals sine x divided by x cosine x. I can separate this fraction so it looks like those rules here. So I'll make it into two fractions. So it's going to be the limit when x approaches 0 of sine x over x multiplied by 1 over cosine x. And remember again, the limit of two functions multiplied by each other is the same as the limit of the product of those two functions. Or sorry, it's the same as multiplying the limits of those two functions. So the limit of this one here is 1, the limit of the second one here is also 1, so it equals 1 multiplied by 1, which equals 1, and this is what we're ought to prove. Another example, let's find the limit of sine 3x divided by x with x approaching 0. Right. What we can do here is we can say that 3x entirely equals u. And so u equals, x equals u divided by 3. And then substitute this. So it becomes the limit when x approaches 0 of sine u divided by u over 3. And so the 3 is a denominator of a denominator, so it becomes the limit of 3 sine u divided by u, with u approaching 0 instead of x now. Because when x approaches 0, then u again is going to approach 0, because if 3x equals u and 3x approaches 0, then u itself is a 0. We do not find limits for it. The limit for any constant is just that constant. The limit of 3 is 3, the limit of 4 is 4, or we can just put 3 to the right hand side. 3 multiplied by the limit of sine u divided by u. And the limit of sine u divided by u is 1, so it's just 3 multiplied by 1, which equals 3. And that would be it. That would be all for today's lesson. I hope it was enjoyable and educational. Don't forget to subscribe so you can easily find all the videos you need, and to write down any request that you have in the comment section so they will be added to future videos. Thank you very much.